Let's look at cubics. So the patterns for a cubic. So it also has a regular pattern. It ends up being a cubed, 3a squared b, 3ab squared, and b cubed. The subtraction one is similar. It's that the signs alternate. So we get plus minus plus minus. We can generalise this to any power. Have you seen this one before? When you generalise it out. A plus b plus c plus however many you got cubed, that pattern exists, just like the quadratic one stayed the same. So you will always get each one of those cubed. You will get 3 times the combination of one of those squared times one of the other ones. So you'll have an a squared b, an a squared c, a b squared a b squared c, and whatever else there is in there. And a c squared a, anyway, they're all there. But you also end up with 6 times when you take them each at a time. So A, B, C, in this case, if that was all that was there, you get 6 A, B, C. But you might, if there were other ones, you might get 6 A, B, D, B, C, D, and so on. So that pattern is always there. Difference of 2 cubes. You've seen this one. You've seen difference of 2 squares. You remember the other day when I said difference of 2 squares, which is more correct? Put the A plus B first or the A minus B? I mean, they're both correct. This is why A minus B is more correct, because they always start with A minus B. So A cubed minus B cubed is A minus B, and then the second one, A squared plus AB plus B squared. Don't make the very common mistake of going 2AB in the second one. We're so used to seeing it, you know, the perfect square, but it's not, it's just AB, AB. There also, though, is a sum of 2 cubes. Now, you don't have a sum of 2 squares formula, but you do have a sum of 2 cubes. Very similar, but notice the difference. It starts with A plus B, and then you have a minus in the second one instead of a plus. Again, that's why you start with the A minus B, or in this case, the A plus B. You match what the question's saying. 2A minus 5 cubed, then, well, whether you do it all in one hit or you physically write each bit down, so it'll be a 2A cubed. The signs are going to alternate. Minus 3 2A squared times 5, plus 3 2A times 5 squared, and then a minus 5 cubed. Notice the powers of 2A are going down by 1. The powers of 5 are going up by 1. At any point, the 2 powers should add to give 3. Tidying it up, there it is. X cubed plus 8, that's the sum of 2 cubes. 8 is 2 cubed. So, again, you might not write that down, but it's x cubed plus 2 cubes, so we'll start it off the way it looks, and it looks like x plus 2. So therefore, in the second one, we go x squared minus 2x plus 4. If it was y cubed minus 27a cubed, that's fine, because 27 is 3 cubed. A difference of 2 cubes, so it's y minus 3a cubed. So we start with y minus 3a, but this time in the second one, they're all pluses. There, we can take it to any power we like. If you've got a to the power of n minus b to the power of n, it always starts with a minus b. Then in the second one, the powers of a go down by 1, the powers of b go up by 1. At any point, the 2 powers, in this case, will add up to be n minus 1, won't it? N minus 1. So if I have x to the power of 5 minus y to the power of 5, there it is. X minus y. And then powers of x are going down by 1. X to the 4, x cubed, x squared, x. Powers of y are going up by 1. So power of 0, which is just 1. Power of 1, power of 2, power of 3, power of 4. Now, that second one could also be factorised, but a little bit of work to be done there. Why is it that we have a sum? The sums will only work when they're odd numbers. Odd numbers. And that's why. Because I could rewrite it to be the difference instead of the sum. Because negative 1 to an odd power will be negative. And you get negative, negative becomes positive. So it won't work with even powers. Because negative to an even power is positive. So it would stay minus. You couldn't get the plus out. So it only works for odds. So we'll end up with a plus 1 starts off the same. Powers of a are going down by 1. Powers of 1, well, you don't write them down, they're theoretically going up by 1. And the signs alternate in this one. So plus minus, plus minus, plus minus, what you got to do. Okay, Now, our textbook doesn't have an exercise on that, which is a shame. But I have photocopied, and I believe it's in the sheets. I seem to remember doing that. The old Cambridge textbook, exercise 1E, some of those.